All right, confidence intervals explained in three simple truths. Simple truth number one, a confidence interval is a range of values. Again, a confidence interval is a range of values. So, what is the interval 3 comma 5 saying? Well, you might be thinking, oh, I know what to do. What you do is you take one of these, and then starting at the origin, I bippity bop over here 3, and then I go up 5, and then look at this. There's 3 comma 5 for you. Where's my gold star? Well, unfortunately, you're dead wrong, so you don't get one. Even though, to be honest, probably in all the math classes you've taken up to this point, you probably would have been right. All right, take it easy. I'll explain. So again, a confidence interval is a range of values. So the interval 3 comma 5 means all the numbers between 3 and 5. And it's very important that you see there where I have 3 comma 5, I have the parentheses. That's very important. Without the parentheses, you're just making a list or you're just basically telling your instructor you don't know what's going on. So as an interval, 3 comma 5 in parentheses represents the range of values between 3 and 5. So for example, 3.21958 would be in this interval. So with this number here we see, as with this number, you get it. All the numbers between 3 and 5, that's what the interval 3 comma 5 means in parentheses. Everything that's bigger than 3 and less than 5. So 3 and 5 do not technically belong to our interval. They are just the limits of the interval. All right, so there you go. That was simple truth number one. Simple truth number two, it starts off the same. A confidence interval is a range of values, but then you're going to want to pay attention to this part. And I hope you're ready because once you know this, you can't unknow it. A confidence interval is a range of values built around a sample statistic. This is a statistics course, right? So a confidence interval always begins with a sample and a statistic calculated from that example. So suppose you have 857 people, or you survey 857 people to see if their main phone is Android or Apple. And uh, the results of the survey are that 243 respond that Android is their main phone. Then you have yourself a statistic. You take 243, you divide by 857, and you get a probability of 0.285, which you could also think of as 28.5%. Okay, so based on this sample, we have the sample statistic that 28.5% of people use Androids as their primary phone. Based on this sample, one possible confidence interval would be the range of values between 28% and 29%. So let's dig into this a little bit more. Again, our sample statistic is 28.5% based on a sample, and one possible confidence interval would be the range of values between 28% and 29%. Now I'm going to ask you something. What is the exact center of this interval? What would be the exact middle number between 28% and 29%? Oh, what do we have here? Don't be shy. You're probably right. This isn't a trick question. A little bit more. Um, you're right. The exact center of our confidence interval is 28.5%, which is exactly our sample statistic. So that's what I mean by a confidence interval is a range of values built around a sample statistic. The sample statistic is going to be in the middle. For example, I made up this confidence interval, right? 28% to 29%. Another confidence interval might be starting with my sample statistic of 28.5%. I could have gone up 1.5% to 30% and down the exact same amount, 1.5% to get to 27%. That this would be one valid confidence interval, as would something like this, where I just go up by a tiny bit. I go up by 100th of a percent, and I go down by 100th of a percent. The point is this, no matter what, the sample statistic will be smack dab in the middle of the confidence interval. That's what I mean by a confidence interval is a range of values built around a sample statistic. You're going to have a window of values. You're going to have a range of values, and right smack dab in the middle of that window of values is going to be the sample statistic that you got from, some study or some survey or whatever. Okay, simple truth number three, aka the why. Why do we care about this? Why do confidence intervals exist? Here we go. We build that little range around our sample statistic. and that range is exactly the confidence interval, to say that the true population value is in that range. That's why we take samples, right? We take samples and we do surveys and we calculate statistics to try and figure out something about the population. And that's what the confidence interval is trying to do. So let's say from our previous example, I did a survey and it turns out from my survey that 28.5% of people use Android as their main phone. So you can say, give me the range of values around 28.5% so that I can be 90% confident that that interval, that range of values, that exactly confidence interval contains the true percent of people whose main phone is an Android. So what would a 90, you can say this, give me a 90% confidence interval. So what I would do is I already did it. It's like a cooking show where it's already done for you. So this is actually and literally the 90% confidence interval based on that study. So what I'm saying that based on my sample of 857 people, of which 243 said that their main phone is an Android, I get a 90% confidence interval of all the percents between 25.822% and 30.887%. So this means that I am 90% confident that the percent of people whose main phone is an Android is exactly between these two percents. Now, what if I wanted to be more confident? See, this interval I'm only 90% confident that this interval actually captures the true population percent. If I want to be more confident, well, I can do that. Here's my 90% confidence interval. But notice I can also calculate a 99% confidence interval, which comes out to this guy. Notice it's a little bit wider, which makes sense, right? If you want to be more confident that your interval contains the actual population percent, you're going to have to cast a wider net. That's exactly what makes you more confident. You're looking at a bigger range of values, so you have a better chance of actually capturing the true population percent. So if I want to build a range of values around my sample to statistic, how do I know how much I should go above and below my sample statistic to be exactly 90% confident that my range captures the population value? What do I add and subtract from my sample statistic if I want to be 98%, I'm sorry, 95% confident? Or yeah, why not? 98% confident. Well, you use math, you idiot. Listen, we're friends now. I'm just kidding around. You're great. I'm actually not going to get into that in this video. In this video, I just wanted to show you the idea of confidence intervals because as an instructor, also as a student, I mean, I took calculus, I got an A, and then 6 months later, I figured out what I was doing. And in with this particular topic, students really try and monkey see, monkey do calculations to create a confidence interval. But when you have no idea what's going on, um, you can't fake it that much. So if you did want to know more about confidence intervals, I get into notation, I get into some examples. Check out the links in the video description, and then you can get more information there. And obviously, this might be a little bit of a old man explaining the internet, but you could just search YouTube for confidence intervals plus whatever you're using, like confidence intervals on Excel, confidence intervals with TI-84, confidence intervals by hand, whatever it is you happen to be doing. Anyway, if this helped, please do check out my blog. If it gets enough hits and views and stuff, I will start beefing it up with more and more stuff.